example 8. Determine the vertical and horizontal asymptotes of h of x equals x squared plus 1 over x squared plus x minus 2. Sketch this graph, label all intercepts and asymptotes. On the last video, if anybody's watching both videos, I forgot to label the intercept. I'll try not to forget that this time. But always label intercepts and asymptotes if they ask you to do that. Vertical and horizontal asymptotes again. So as far as vertical asymptotes are concerned, we consider the bottom of the function, and we want to see where that thing equals 0. So if I take a look at the bottom, vertical asymptotes, x squared plus x minus 2 equals 0. That's factorable, x plus 2 times x minus 1, which means x equals negative 2 and x equals positive 1. Both create a 0 in the denominator. Again, we do have to verify those numbers don't make zeros in the numerator. Looking at the numerator, x squared plus 1 can't equal 0, right? But if I tested them out, 1 squared plus 1 is 2, negative 2 squared 4 plus 1 is 5, neither one's 0, so both of those are vertical asymptotes. I'm going to save the vertical asymptotes, graphing them until we get some numbers here, just in case I have to scale. All right. But again, when I do actually graph, the first thing I graph are the asymptotes. I always get my sections all figured out there. All right. As far as horizontal asymptotes are concerned, we only have to consider for horizontal asymptotes the highest power on top and the highest power on the bottom. In this case, x squared on top, x squared on the bottom. If I do x squared over x squared, I get 1, so y equals 1 is the horizontal asymptote. So as far as determining the asymptotes, I've already done that. Okay, horizontal asymptotes are what they are. There's no like checking that to make sure something else happens. No. Same power, so they reduce out to a number, y equals that number. The graph's going to approach that. All right. As far as intercepts are concerned, x and y intercepts. As far as x-intercepts are concerned, we only care about the top equaling 0. I think we've already established x squared plus 1 can't equal 0, which means there's no x-intercepts. This graph will never cross the x-axis. All right? Because again, in order for a fraction to equal 0, it has to be 0 divided by number. In this case, the top cannot equal 0, so the graph will never cross the x-axis. As far as the y-intercepts are concerned, we let x equal 0, so h of 0 is going to be 0 plus 1 on top, and 0 plus 0 minus 2 on the bottom. So h of 0 is equal to negative a half. So, as far as points are concerned here, x, y, 0, comma, negative a half. And I'm graphing, so decimals probably rather than fractions. Alright, so I'm ready to start picking values. Alright, so as far as picking values is concerned, let me just highlight this. If x equals negative 2 is a vertical asymptote, so just assuming it's going to go here, okay, we might scale, we'll see. But assuming it goes here, I want to pick values very near negative 2. So a half, 1, and 2 to the left, a half, 1, and 2 to the right. So if I'm picking those values, negative 2.5, negative 3, negative 4 would be to the left of negative 2, but close. Negative 1.5, negative 1 and 0 will be to the right of negative 2, but close. For the other asymptote, x equals 1, to the left of 1 would be 0.5, 1, and negative 1. Or sorry, 0.5, 0, negative 1. We've already got 0, negative 1 taken care of, right? So 0.5 also is included to be close to 1. But all three of these numbers here are close to 1. All right? Going on the other side of 1, 1.5. 2 and 3 would all be close to 1. All right. So again, as far as that chart, that process is concerned, if there's vertical asymptotes, pick numbers near that. That's what I mean by that. So at this point, I'm going to go to my calculator, go to y equals. I'm going to enter my function. Got x squared plus 1 on top, divided by x squared plus x minus 2 on the bottom. I'm going to go to my table, enter all the x values that I've determined to use. Negative 2.5, negative 3, negative 4, negative 1.5, negative 1, 0.5, 1.5, 2, and 3. A nice outfit. Okay, again, a couple decimal places on each one. So negative 2.5, 4.14, negative 3, 2.5, negative 4, 1.7, negative 1.5, negative 2.6, negative 1, negative 1, 0, 0, negative 0.5 we already actually had. I'll just put it there again. I'll cross it off there. 0.5, comma, negative 1, 1.5, 1.86. 2, 1.25, and 3, 1. Alright. I want you guys to notice something real quick that just happened. And it might not be something that catches your eye right away, but hopefully as you continue to practice the skill and get good at it, you'll notice this happening. 3, 1. What's the horizontal asymptote? 1, right? So we have an x value that leads to a y value that represents your horizontal asymptote. So again, that's still near 0, right? Again, that can happen. As you're near 0, that horizontal asymptote can be breached. All right? But you need to get more information beyond that breach point to find out what happens after that. All right, so what I would do probably at this point, since I got that happening, is take this chart and slide it over here, get some more chart. I would pick numbers, so 1, 2, 3, 4, 5, 6, 7. I can go all the way to 8, right? So I'm going to go 4, 5, 6, 7, 8. Just to see what happens. I might even, if I'm feeling really crazy about this, I might go 2.5 and 3.5. Just to the left and just to the right of the breach point to kind of get a feel for what's happening as it crosses that intercept, as it crosses that asymptote. Those last 2 points may not be necessary in the whole scheme of things, but again, the more points you plot, the easier it is to visualize what the graph's supposed to look like. So, if I go back to my calculator and start typing those numbers in, sure, 7, clear quicker. 4, 5, 6, 7, 8, 2.5, 3.5. Alright, so for 4 I get 0.94, for 5 I get 0.93, 6 I get 0.93, 7 I get 0.93, 8 I get 0.93. It's kind of boring. They're all different 0.93s, right? Notice 928, 925, 9259, 928. So it gets smaller, start getting bigger. So at 6, it hits a low point, then it starts getting bigger again. At 2.5, it's 1.07, and at 3.5, it's 0.96. Okay. Over on the left side, over here, I've got 4.14, 2.5, 1.7. Looks like they're behaving more, right? They're staying above 1. It doesn't look like they're trying to go to 1. So I don't really have to pick those numbers going further that way if I don't want to. I could if I wanted to. I could pick -5, 6, 7, and so on. Again, if I just want to get really technical about this, -5, -6, -7, -8. You can see they're staying pretty much above 1. They're nearing 1, but they're not going close enough. So they're getting far enough away from 0 that I don't have to really worry about them crossing that. So it should be pretty straightforward. They're going to just kind of level out around 1. So we'll just leave those points as extras. If we really wanted to graph them, we could. So negative, so I've got all my information there. I don't see anything ridiculously large here, so I don't have to really scale anything. So now I'm ready to start graphing everything. First thing I always graph is my asymptotes. Vertical asymptotes, -2 and +1. Horizontal asymptote 1. All right. Again, if there was any scaling being done, then I would want to go ahead and deal with that, but I don't have to do that. Here we go. All right. Then I start plotting my points. I've got -2.5, 4.14, 1, 2, 3, 4.14. Be careful when there's vertical and horizontal asymptotes around that your x and y axes are both labeled. They're counting from there when you're plotting points. I've seen people count off the asymptotes instead of off the axes. So I'm here at -1, -2.5, 1, 2, 3, 4.14. -1, 2, 3, 1, 2.5 will be here. -1, 2, 3, 4, 1.7 will be about right here. Looking at this, if I'm trying to connect the dots, it looks like it's rising as it gets to the asymptote. It looks like it's leveling off, gets towards the horizontal asymptote. So I would expect it to kind of level off here. We've already seen that with our values. And then go up. That's one section of the graph. I don't have to graph any other points to get that section. The vertical asymptote is a break in the graph that cannot be breached. So as soon as I get everything to the left of that asymptote, I can connect those dots right away and I'm ready to go for that. The next section of the graph is in between these two vertical asymptotes. These four, let's see, this one, this one, this one, this one, this one. Nope. There we go. those 4 points marked in green are all between those, right? So if I plot those, negative 1.5, negative 1, 2.6 would be about here. Negative 1 is right here. 0, negative a half is right there. And 0.5, negative 1 is right there. And again, what I want to do is I want to visualize how to plot those points, how to graph the line here, or the curve. Okay? Going towards that asymptote, they're going down. Going towards this asymptote, they're going down also, right? So I can imagine they're both going downward. As far as this, though, connecting the dots, do I go straight from here to here? Does it go up a little higher, something like that? Maybe I want to pick a couple extra values. So I'm going to pick negative 0.5. Just to get an extra value in there, just to kind of get an idea. Negative 0.5 comes out to negative 0.56. Negative 0.56 would be about here. This is negative 0.5, right? Negative 0.56 is like right there. A little lower than that. So it's still reaching up. So it looks like it's kind of doing what I said. So we're going to make it come near the asymptote and then kind of go back down. Looks something like that. Again, if you aren't comfortable connecting those dots, if you don't have enough information, pick more X's, get more Y's, plot the points. All the points that you get are points on the curve, so the curve has to go through them smoothly. They're not going to be these weird, just jumping around stuff going on. All right. The final section of the graph is over here. Again, vertical asymptotes separate the graph, so I can go ahead and draw that with no harm done. The last section, starting at 1.5, comma 1.86. So 1.5, 1.86 would be about here. 2, 1.25 is about here. 3, 1 is right on the asymptote. We have 2.5, 1.07 just above. And 3.5, 96 just below, right? And then we have 4, 0.94. We have 6, 5, 6, 7, 8.93. They're all the same. So basically it just dips below and then it just starts kind of easing its way back up. It's going to stay below it. So that's what's going to happen. It's going to come down here, go through the horizontal asymptote, hit a low point, and then start kind of creeping its way back up, like so. Give yourself enough variance here that go down, even though 0.93 obviously is not far down, go down far enough so I can see that you meant to go underneath the asymptote there when you're graphing it. All right. And as far as labeling stuff, vertical, horizontal asymptotes, VAX equals 1, VAX equals negative 2, HA Y equals 1. There's a y-intercept, there we go. Y-intercept 0, negative 0.5. Okay, so labeling your graph like that, please, when you do those. And once again, can we verify everything we did? 1, 2, 3, 4, 5, 6, 7, 8. So negative 8 to 8 on the x-axis. And 1, 2, 3, 4, 5, 6 down, 1, 2, 3, 4, 5, 6 up. So negative 6 to 6 on the y-axis. Hit graph. Your graph should look very similar to what we have. Again, somewhat rectangular. It looks very, very close to what we have. So it just gives you good confidence that what you did is correct based on what it's supposed to look like.